The world of mirrorless cameras is bracing for what could be one of the most significant shakeups in the APS-C market. For months, rumors and leaks have circulated regarding the successor to the highly acclaimed Fujifilm X-T6. The incoming details surrounding the highly anticipated Fujifilm X-T6 point not just a minor, incremental updates, but to a massive technical evolution designed to completely redefine what a crop sensor camera body can achieve. This upcoming flagship is generating incredible buzz among photographers, filmmakers, and hybrid content creators who value tactile gear paired with cutting-edge internal performance. The core of this excitement lies in a radical new sensor architecture, massive leaps in internal video recording capabilities, advanced thermal management solutions, and a completely overhauled artificial intelligence autofocus tracking engine. Together, these enhancements aim to eliminate the common pain points that have historically led professional creators to transition away from APS-C systems in favor of more expensive full-frame setups. For the first video, which serves as a comprehensive deep dive and full breakdown of the leaked specifications, the narrative centers on how this body serves as a direct technical response to the limitations of previous generations. While the previous camera brought an exceptional 40-megapixel resolution that delighted landscape photographers and studio artists who required massive files for heavy cropping and large-format printing, it was not without its notable drawbacks. Professionals frequently noted that while the autofocus system was highly competent, it lacked the tenacious, sticky tracking reliability found in competitive bodies from Sony and Canon. Furthermore, intensive video production often pushed the hardware to its thermal limits, requiring creators to be highly vigilant regarding continuous recording times and ambient operating temperatures. The leaked specifications of the upcoming system suggest that every single design choice was engineered specifically to address these exact criticisms, transforming a niche street photography tool into an uncompromising, heavy-duty production powerhouse. The defining element of this new system is the heavily rumored 40-megapixel partially stacked X-Trans CMOS 6 HR sensor. To fully understand why this is a revolutionary development for the product line, it helps to examine how standard sensor designs function at high resolutions. High pixel density typically introduces hardware bottlenecks, specifically relating to slower sensor readout speeds and pronounced rolling shutter artifacts when panning across a scene or tracking fast-moving subjects. By adopting a partially stacked design, the manufacturer integrates dedicated memory layers directly between the pixel array and the underlying logic circuit. This architectural change acts as a physical turbocharger for data processing, enabling exceptionally fast readout rates. Consequently, rolling shutter distortion is expected to become virtually unnoticeable, allowing sports, action, and wildlife photographers to capture rapid movement with perfect geometric accuracy. This faster sensor readout also unlocks significantly higher continuous burst rates and remarkably more responsive real-time focus tracking, bridging the physical gap between compact usability and professional sports-grade speed. Equally transformative are the leaked internal video capabilities, which position this compact body as a legitimate professional cinema tool. The system is rumored to support internal 8K video recording at up to 30 frames per second, capturing pristine detail in 10-bit 422 color depth. For a body of this physical size, such processing power is immense. To elevate its professional appeal even further, the leaks indicate the capability to output 12-bit ProRes RAW and Blackmagic RAW files directly via the HDMI port to external monitors and recorders. Recognizing that high bitrate 8K recording generates massive thermal energy, the design reportedly incorporates a specialized internal heat management structure, with strong whispers pointing toward a dedicated fan-assisted cooling system. If the camera can successfully sustain extended recording durations without overheating, the entire value proposition changes for working videographers. It ceases to be merely a lightweight secondary B camera and transforms into a primary, reliable A cam capable of anchoring demanding commercial sets and long-form documentary productions. For the second video content, the focus shifts to a direct side-by-side comparative analysis, pitting the new flagship against its immediate predecessor as well as its main market rivals, such as the Sony A6700 and the rumored Canon EOS R7 Mark II. In the competitive landscape of modern mirrorless systems, specifications alone do not tell the full story. Implementation, ergonomics, and color science dictate how a tool performs in the field. When compared directly to the older model, the visual identity remains deeply rooted in the physical analog design that users consider sacred. The iconic top plate dials dedicated to shutter speed, ISO sensitivity, and exposure compensation are not merely